Dahad. Welcome to this edition of Silicon Grapevine. My guest today is Brijesh Tripathi, who is CEO and co-founder of a company called FlexAI. Brijesh, hello, how are you?
I'm doing very well, Nitin. How are you doing?
Good. Well, Brijesh, before we go into your journey, tell me a little bit about FlexAI. It started in 2023. You've raised $30 million in funding. France headquartered at the moment.
Yeah, Nitin, thanks for asking. We started our company in 2023, headquartered in France, but we have three offices, one in Santa Clara, one in Bangalore, and obviously the headquarters in Paris. Our goal for FlexAI was to solve the big challenge of AI compute infrastructure. So what we saw with ChatGPT explosion was the demand for compute grew exponentially, but supply was obviously very restricted. And it was mainly because it was just delivered by one company and one infrastructure, which is mainly CUDA. And when you think about the type of workloads that were coming, they needed a bit more variety, a bit more options. And when we started the company, one of the biggest asks was, there are other options in the industry. Can we enable them and make use of them? Because, that supply versus demand was almost 10:1, or demand versus supply. And there were other options that were still sitting at the table, but not actually getting used because of the complexity around software. So we started this company to deliver some of those additional compute into the infrastructure using FlexAI Cloud. So we just launched the service this year called FlexAI Cloud service. And the idea there is it's the first heterogeneous AI cloud service that will deliver compute as PyTorch as a service. So customers can bring their models, their data, and then train without understanding or knowing or building the infrastructure behind it. And we're changing the dynamics around how people use and build AI compute too. So instead of renting GPUs for dollars per hour kind of basis, and then figuring out the networking, figuring out how it operates, figuring out the failures in MTBF, we just let them use it as a service. Almost like think about how you will launch an EC2 instance on Amazon today and just start running your services without understanding or knowing where the system is, how it's operating, and what the workload, what the background infrastructure and failure rates are. So this company's purpose is to deliver more compute while reducing the complexity of using that compute. And we are on our first step of that journey.
So there's a couple of things there. I mean, architecturally, I think you're doing things differently, because I think you've talked about how you need to be different and not just doing the same thing and just sort of putting more and more horsepower into the GPUs.
In fact, our first instance of our cloud service has NVIDIA and AMD in our solution.
Okay.
And what we want to deliver is PyTorch as a service instead of GPU as a rental.
Got it. So you're going higher up the stack, basically. Okay. And I think that's what, from what I've understood, that's key to sort of enabling adoption beyond just one company.
Exactly. And one of the things we have been wondering about why some of these companies in the last 7-8 years are in the graveyard. And one of the challenges was they all went after CUDA or NVIDIA's silicon. So It was all or nothing or a replacement option. What we are working on is our customers don't have to worry about their workloads running. It is guaranteed to run. We look at the most important workloads of the season. Today it's Transformers, tomorrow it could be Transformers 2. Day after tomorrow it could be some other new variable. We take a look at the highest volume of compute and start spending time in mapping it to the most efficient and cost-effective architectures in the industry, which potentially could be our own too eventually. But that work is done by us, and we see that workload, we put it over there without needing customers to do any work.
Okay.
If those are not working on those new architectures or more efficient architectures, they continue to work on the most expensive ones, and that's okay. And I think that differentiation allows more people to play in this game, more architectures to actually come in and become relevant and useful for this industry.
Well, yes. I mean, I've been reading the financial newspapers with all kinds of analyses on who's going to challenge companies like Nvidia. So it is quite interesting. But let's move a little bit. We can go on a different discussion about this forever. But your journey, you've been 24 years. I mean, you've had Nvidia, Apple, Tesla, Intel on your CV. It's quite impressive, and the work you've done, you've spent quite a lot of time on various projects. But how did you get into electronics in the first place? I mean, you come from a place in India where you weren't actually exposed to a lot of this, and maybe your parents didn't even know what the college was that you were going to want to apply to.
Yeah, yeah, it's a fun story I tell people when there's a lot of time and I am actually in the right mood. But it wasn't a straightforward path of getting here, Nitin. When I was growing up, I was growing up in a very poor family. We had very limited resources. I grew up in Kanpur, which is the same college. IIT Kanpur is where I went to. But I didn't know about IIT Kanpur when I was growing up, mainly because, my parents were just about able to feed us and send us to some school. We couldn't afford a house in the middle of the city, in the town area. We were outside the city. And the power situation used to be actually bad. So every evening, because of the overload on transformers, our voltages would drop to like 50 volt on a 220, 240 volt expectation. We would get 50 volt, 40 volt. We couldn't see, we couldn't read, I couldn't study. And we used to have this battery backup for our power because we would lose power all the time. And we used to have this 12 volt battery that had a charger. And that charger had a transformer. And I started reading a bit about it. This was 6th grade. So I'm probably 10, 11. And I realized that it's a step down transformer. It basically takes 240 volt, converts it to 12, and then rectifies it using some diodes. It's like, if it can take 220 volts and bring it down to 12, it should be able to take 50 volt and bring it down to higher voltages. And literally, I just tried it and it worked. I was like, this is good. This is cool. This is what I want to do. And I didn't know this was electrical engineering. By the way, this is power electronics. But I was like, this is what I want to do. And I want to figure out how to do this as my profession. So as I grew up and I started understanding more about, what my choices are, I realized, there is a college right next door that I can actually go to. I didn't actually know that I have to write JEE to go there.
But also, it's quite difficult. It's quite difficult to get into the IITs as well. So that's even a bigger challenge.
That was something I realized after I sat for the exam.
Okay.
I wrote the exam. I got like 189 or something rank in JEE. Apparently, again, all of this naivety, right? I didn't know that 300,000 to 500,000 kids sat for that exam then. And right now it's probably in millions. And only 3,000 of them got in. So the ratios were completely off. And I had no idea that's what I was competing for. And when I got in, I was like, wait, these kids are all smart. I'm at a different company now, right?
Exactly.
And I started getting more and more interested in electronics. I started getting into analog design actually at that time. Got into CMOS analog design with the professors over there. And then right at the end of those 4 years, NVIDIA was just about getting an interesting deal from Microsoft. They got selected to build Xbox. And this was the first time they came to India to hire from IITs. And I was one of the first people to come to US from IIT.
That was in around 2000? Around 2000?
It was year 2000. In fact, in 2001, Nitin, I went with Chris Malakowski, who is the co-founder of NVIDIA, back to India to hire from my same college or colleges in IIT, the next batch. And that was fun too. That was very, very fun.
That must have felt very strange.
It was sitting in visitors' hostel instead of my own room in Hall 1 in IIT. It felt very, very different. And kids coming to you and you're interviewing them. Like, wait, I was here on the other side last year. But it's an exciting feeling.
But at that time, NVIDIA didn't have that aura around it as it does today, obviously. But I think it was still, for you sitting at IIT Kanpur, probably a big thing.
Yes, and the thing is, most US companies did not hire directly from the college at that time.
Okay.
NVIDIA was
Yeah.
one of the first US semiconductor company that actually started hiring from IIT, and it was very clearly one of the best options available at that time. I got interviewed by Gopal Solanki, who was the VP of engineering at that time. He
Okay.
was my boss at NVIDIA, and he went to, I think, Chennai, and he explained, hey, look, this is one of the best opportunities that you can get here in India and in US, and we are going to do great. He didn't know about this ChatGPT stuff, but in terms of gaming and chipset architecture, NVIDIA was definitely one of the best companies around.
It was, yeah. And so you moved from India to the US straight away, or working in there first? Okay, yeah, that's pretty good.
No, I moved to US right away. I graduated in May. I was here in June, starting to work for NVIDIA. We had to wait for a few months for our visas and stuff, but it was right out of college. I was here in Santa Clara.
Okay, and so what are the things? I mean, from NVIDIA you went to Apple. Is that because you saw opportunity, or something new, or somebody said, "Hey, I like what you're doing, and I want you here"? Because I think it's quite interesting to see what the theme is here.
Yeah, Nitin, it's been one of those things. I don't want to call it's a 7-year itch, but for at least 2-3 times I felt that was it. But it wasn't really that itch. It was wanting to know more about the higher level team, right? When I was at NVIDIA, I was a chip designer. I became an architect for various modules that went in the GPU, memory controllers, host, display, media. And, you get to learn a lot. You get to learn your coding. You get to learn your Verilog. You get to learn your chip design, debug, bring up. But you still are missing on what is it used for? Where is this chip going to be used? And obviously for NVIDIA, it was, gaming machines, desktops.
Correct. Yeah.
Gamers are using it. But I was like, but there are more things in a computer. It's not just games that run on a computer. Like, what else happens in a computer? What do people use computers for? What are the workloads? What are the use cases? And I kind of was in search for this higher level understanding of the computer architecture and the utilization and the usage of it. And one of the opportunities that came my way was, hey, we are a systems company. At that time, Apple used to call themselves a systems company. It was still not a consumer electronics company. It was a systems company. And they said, we want to get into chip design.
Wow.
But we are coming from a systems side.
Okay. Yeah.
I was like, I know chip design. Let's go do it together. And I was part of a team that was 25 people team at Apple at that time.
2007. Around
2007. Yeah. So we started
before iPhone,
design.
just before iPhone.
Actually, iPhone was announced. The funny thing is, 2007, they had announced the first iPhone. I joined them in August. They had announced it in June. Yeah, so I was off by 3 months, except that chip was completely owned by a different company.
Yeah.
Was sourced by from a different company. It was specified by Apple people, but it was not very high quality. I know how many hacks we had to put in there to make that phone work, the first one. But that was one of the biggest reasons why Apple decided to say, we got to own this entire experience, which means we need to own the silicon. And we started designing things with 25 people team. The partner was still the same big manufacturing house in Korea. That team now is 17,000 big. The team that I started with, that was 25 people. Johnny Shruji was the guy who was hired from Intel at that time. I interviewed him and he became my boss. And, we worked on the first chip that went in Apple iPhone 4. It was called A4. Internally, it had a different name, but that was the first chip that came out of my work.
Wow. Okay. Well, you must have felt really proud. But I mean, that's not enough, because then you moved on to Tesla, and then Zoox, and then Intel. What are the highlights there before we talk a little bit about your experience doing the 60,000 GPU machine supercomputer?
See what this is somewhat of, it's very likely a combination of my desire to know more, learn more, and get deeper into different technologies. I kind of, around to 2015, by that time I had filed probably 70 plus patents at Apple. You can imagine a lot of innovation, a lot of inventions, a lot of creation, but it wasn't enough. The desire to actually go now take this, because once you get into a rhythm of building phones every year, you're like, okay, what's next, right? Phones are done. I need to go solve some new problems. And that kind of kept, in the back of my mind from 12 to 15, we were on this path of being the best. The RSOCs were best in pretty much every single metric we could imagine. I used to spend hours, days, weeks optimizing a milliwatt of power on our chips, on our architectures that we were building. That would save, hours of battery life, so people can actually go longer on their, computers are in their pocket.
Exactly. Yeah.
However, it had a limited scope of the next big thing. You had finished doing the experience part of it. You have now the next level of experience coming from the cloud, because you can only fit so much in a pocket. So I had this interesting opportunity coming my way around 2015, where Elon was getting into, let's actually become a computer company from being a car integrator. And he started putting together a team of semiconductor technology experts in-house. And it wasn't very clear initially what he wanted to do with it, but he was like, if we want to own the same thing that was happening with phones, that Apple did with phones, he wanted to do with cars. He's like, I need to control the experience. I need to control the cost. I need to have more of my own architecture driving the lower level components. And so he hired people like Jim Keller, myself, Pete Bannon, and a few, and James Atwell.
My ex-colleague, James Hickwell.
James Hickwell, we were the first technologist in Tesla. And prior to that, it was mostly a computer or a car integration company. So components used to come from Bosch, Continental, Aptiv, Vallejo, and engineers would plug them together based on a mechanical engineering or electrical engineering design files. And what Elon wanted to do was take more control of the entire stack, including the chips. And so that's what we started doing there. One of the things that I when I was talking to folks at Tesla, they asked me, what do you know about cars? I said, I think there is an engine in the front and there's a gas tank in the back. And I just know how to drive. And like, good, we'll all figure this out together. And that's the same story I had, or I told it. I had those discussions for the next, 50 people I hired. I would ask them, what do you know about cars? And they would all just say, not much. And I like, you were hired because we needed technologists and not car builders, because we were going to rebuild the car from bottoms up, brand new architecture. That experience, I think, people ask me, what is the best experience out of all of these different places? I still rate the Tesla experience as the most fun.
And was that very visionary, do you think? Do you think it's quite visionary to do what he did?
Yeah, and he sees the future. It's not obvious to people at the time he can see it, but when you get there, you're like, that's the obvious choice to make. And, after what he did with Tesla, GM, Ford, Toyota, BMW, Mercedes. Imagine these companies. I mean, they have been around for decades. Now they are jumping in the same thing. I was talking to the CEO of Global Foundries, Tom Caulfield, recently, and he's like, Brijesh, these car companies are coming to me and they want to build chips, and they don't know anything about chips. Can you help me? Can you be the interface between the car companies and us? Because I don't want to deal with people who don't know how to build chips. They're talking about wafers. They haven't seen a single line of Verilog before. And I think that regardless of what we do there, that mindset of we need to own more of our architecture, more of our product, more of our design is his thinking, is Elon's thinking. And I think that's definitely a visionary thought process.
It definitely kick-started the whole thing. Yeah, because
absolutely.
I remember seeing him 3 years ago at a keynote speech at a Future of the Car conference in London. And the story he tells of how Tesla came about is just very impressive, very amazing.
Yep. I mean, I'll tell you a quick anecdote on my experience working directly with Elon. I used to work for him for some time. I was working on, I think it's public, but it's semi-public. I was working on an RF technology that may or may not exist in his cars anymore. But it was a futuristic RF technology, beamforming and stuff.
Oh, okay.
So I'm not naming the thing because, he doesn't like the name. But I was working on it. It was an approved project. I had 15 people working on a chip design and the whole big radio antennas and the whole mechanical box. We were going to do a full design, replacing one of the tier 1 suppliers with our own design, obviously 1/4 the cost and 10 times the performance. And as I was building it, one day he calls me from LA and says, Brijesh, do you think RF signals can travel in space? I said, yes. Okay. So can you use your chip to communicate between satellites? I said, depends on the bandwidth that you need, depends on what you want to do with that. It's like, I'm tired of all of these guys trying to align laser beams in space. It's just super tedious process, and it has to be precisely aligned to actually receive.
Yeah.
RF, you can do beamforming. This is his understanding of what I'm working on. Like RF, you can do beamforming, and it's not that hard to align because it's electronically done. I said, it's a good idea. I just need to do more physics study on this in terms of the bandwidth available, the needs that you have, and then we can figure it out. And he's like, why don't you come over to Seattle tomorrow? Let's have a meeting with the satellite folks. And I did that. I mean, obviously I sat down with the satellite folks. We talked about a whole bunch of things. It probably wasn't the right answer, but think about the first principles thinking that he does. And then we sit down and talk about some fascinating inventions that nobody has thought about before.
That is good. That's a great story. In fact, I'll probably use that as the trailer for this interview. But no, there's the other thing. I mean, your PR people told me when they introduced me to you is you're designing this really big supercomputer, 60,000 GPUs. Tell us a little bit about that with Intel.
Yeah. So Nitin, I'll give the credit to the right set of people. This project was started at Intel long time before I had anything to do with it. I used to build technologies, chips that were 10 watt kind of power range, maybe 50 watt. If you include the Tesla Autopilot in there. So always optimizing power, always optimizing performance within the power envelopes and all. I had never dealt with high performance machines prior to joining Intel, right? It was not something that I had personally done. I knew about them, and I kind of understood why they were high performance computers needed, because the large size data sets in the simulation time, they were simulating weather on these computers. That's how I knew about HPC. But in 2020, Pat Gelsinger asked me to look at the HPC architecture and said, hey, I think we can do some innovation there. I think it has been kind of stagnant for some time, and you can go take a look at it and see if it's interesting. And interesting it was. I went and I studied the HPC architecture for a few months, and I came back and I told Pat one day, I said, Pat, now I know what is high performance computing and large scale computers. He's like, tell me. I was like, it's just a collection of a very large number of small computers. It's just the same architecture connected at scales of thousands and thousands of them connected over a network. All we are
Exactly.
doing is adding a software layer to make them feel like one.
Yeah.
He's like, okay, that's true. That is exactly what it is. I said, guess what? I already know how to build the most efficient small computer. So if you want to do more with less, which is power and dollars, let's make a better small computer and make sure it is designed to be scalable. So don't think about scaling as an afterthought. And the first thing is, put as much compute as you can, pack it into a single box. Because it is a scalable computer, you don't even care what is in a single box. You just
Yeah.
care that you can scale it to an infinite level. And in
Okay.
a single box, you can put the most efficient computer. I did a hypothetical for him. This is, again, one of those interesting stories. I went to Pat. He took it to the board, this specific incident. I compared it to, I can say, I compared it to the Aurora program that I started working on. Aurora is the largest supercomputer built at that time. It started in 2017, had a very different architecture. It was supposed to have an accelerator kind of architecture instead of the GPUs that went in there eventually. Went through 2 iterations of architectural changes. By the time I saw it, it was a more traditional GPU-CPU combination scaled over a network architecture, which is more traditional AI supercomputer kind of architecture. But when I looked at that, and I compared it to the 50 plus megawatt of power that went into it and the performance we got out of it, I did a side-by-side comparison, and again, hypothetical comparison, just to show my point. If I built in the same power a computer made out of M1 chips, which were already released by Apple by that time,
Yeah.
I would get 10x more performance without inventing a single new thing, except for M1s are not designed to be scalable. There is not enough networking and IOs in there. But hypothetically, if I put the right amount of IOs and planned it to be scalable on day one, the same architecture that went into the laptops would actually give you 10x more performance for the same power as Aurora did. And I just showed it to Pat, and he's like, that makes sense. It's because you designed the unit level at the most efficient level. And he took it to the board, and that's how I got approved for my next project, which I was working on before I left Tesla. But Aurora itself was a big, massive stepping stone for me, Nathan, because architecturally I can boil it down and break it down into smaller pieces that are easy to understand, small computers, large scaling, software, making it look like one. All of that makes it simple, right? You and I are like, okay, this is easy to understand. But the fact is, large is still a large computer. And that means it comes with its own set of problems. Networking is the biggest problem of a large-scale computer. In fact, when you read papers on ChatGPT or GPT-3 training or Llama 3 training, the biggest challenge that people are facing is reliability. They fail. When you have computers that are in orders of tens of thousands, something fails all the time. The MTBF on the computer that ran Llama 3 was 3 hours. Every 3 hours, something failed.
Wow.
The MTBF on my computer was in that same order. I won't tell the number, but it was in the same order of magnitude. Guess what? If you have a simulation that needs to run for days, weeks, months, sometimes,
that's not good.
You cannot run it because every 3 hours, every 8 hours, it will fail.
Yeah.
So you have to think about checkpointing, saving states, restarting. You have to think about other optimizations. You have to think about power surges. When everything, Elon talked about this recently. Again, he's a smart guy to realize where the challenges are. His whole 50,000 GPU cluster that he's setting up. I was dealing with this 2 years ago. When you turn on the computer and you say, go run this workload, the whole town can actually be out of power for that instance because the surge is so high. But we have to prepare for that. We have to make sure that we can feed it. Then comes the networking. When you're dealing with 60,000 GPUs, 20,000 CPUs in a single cluster working on a same problem, the amount of data that is actually moving, it's a chaos. the congestion is a nightmare. Guess what? As a mobile and laptop and autopilot computer architect, I never had to deal with congestion problems.
It's like a 101 on steroids or 405.
101 on steroids right next door. I'm like, I know, I've seen this before in practical life. Let's actually spend time figuring out what to do with it. Guess what? The funny thing is, you can apply so many different technologies in there. Waze solves the problem of 101 for me. When I get out of my house at 8 in the morning, I know I'm not going to take my standard route because it is congested. So Waze routes me through some smaller, tiny streets, but I get there on time, I get there sooner. Same thing applies to networks. Congestion controls are basically finding alternate routes and reducing load on the most congested nodes. That's something that we are going to design our architecture, our future architecture with, which is build in the congestion control instead of thinking about this as an afterthought. Lots of learning from that.
This is FlexAI.
At FlexAI, yes.
So we should sort of be wrapping up soon, but I think one of the things I wanted to ask you, what sort of took you away from Intel into this startup world?
One of the things I've realized is I'm a bit impatient when it comes to getting things done. And, Intel is going through its own
challenges,
finding itself. Everybody knows about those challenges and all that. It needs to find its own place again in this industry. Intel is the company that I looked up to when I was in college. I learned programming on 8081, 8085. Those were the computers I first programmed in assembly language. When I came to US, actually, I joined NVIDIA, which was right next door to Intel. And every day I would drive from my home to NVIDIA, and there's a stop sign and there's a light at the intersection of Intel. I would look up and say, one day I'm going to work at Intel. And these are my first few years of being in US and working at NVIDIA. I'm still imagining I will work at Intel because I look up to that company. And when you look at it right now, it's a very difficult situation. It's a very sad situation, but it's also an iconic company that really needs to be there. If you want to maintain self-sufficiency in terms of semiconductor and supply chain, and your ability to build your own chips, as the world gets more and more isolated, Intel needs to find its place. However, at a personal level, that's going to slow me down in the time where I have innovation ideas, where I have things to do, things to actually create and solve real problems in the real world right now. So, after having a bit of, conundrum about, what should I do with the chaos and challenges within the company, and I have to actually go implement some of my ideas in a faster way, I made the decision that I need to get out and actually do it on myself. And I talked to Pat, and he was, after a bit of negotiations, he was supportive. And in fact, that's how I started. I started with a very strong support from Pat. We started with a very strong partnership with Intel. And in fact, as I was talking about, our FlexAI cloud architecture is a multi-architecture, heterogeneous architecture. I had promised that we could put Intel solution in there when it's ready. So, that was a hard decision, but it was probably the right thing for me to do.
Okay, sounds good. Let's move on a bit. So one of the things in your career, like inspired you, meant that you thought of good people behind you who mentored you. Is there anything that you really want to sort of pick out or highlight? I know you're a big problem solver, but at the same time, there must be things that inspire you.
Absolutely. Look, I mean, every step of the way, I had someone to look up to. When I was in college, I picked up a couple of my professors who were experts in analog and digital design, and I just kept following them, learning from them. That motivated me to actually go deeper into the subjects that I was taking. When I went to Stanford, I followed Mark Horowitz and a couple of other professors around to basically learn from them, from their life experiences. my first big mentor moment came from my Apple days. I had been there a couple of years, and then this guy joined called Jim Keller.
Oh, yes. Okay. Yeah.
He walks in slippers the whole year. It's summer, winter, rain. He doesn't wear shoes, and he's an architect. I'm an architect, and we sit in the same rooms. I was like, who is this guy? And I introduced myself, and a friendship started. So we have now known each other for 12 years. And
Wow. Okay.
I look up to him as someone who doesn't see problems as something difficult to solve. He sees problems as opportunities, and always goes back to, there is a better way of solving this. Whatever we did this year, there's another way. There's a better way of solving something. And I think that's kind of the motivating factor for me, which is I'm never satisfied with what I have done so far. There's always something better to do. And while I was at at Apple, it was very interesting. I used to work on the iOS product side, so phones, tablets, Apple TV and all. But there was another segment of product that was at Apple, MacBooks, and they were built on Intel platforms at that time.
Yep.
So I wasn't that close to that group and that platform, but I had fascination about, okay, what goes in there? Why is it not? Why can't we put our chips in there? What's the difference between these and ours? I met Raja Koduri there.
Okay.
So he used to work at Apple then too, and obviously no direct, professional paths crossing, but we were just, friends. I used to go to his lab. He used to be on the graphics side always, right? So I used to go to his lab. He used to have all these fancy futuristic gadgets, this kind of display, that kind of display, this kind of graphics. I used to just have so much fun. He still talks about those days as I used to be like kid at a candy shop. And I would be so excited. And I think he became another mentor that I look up to. I definitely actually talk to him on various architectural topics. These two guys motivated me. At Tesla, Jim and I worked together on building those autopilot computers and all. And at Intel, they were both there, and they were the reason I joined Intel. So yeah, these two guys I carry on with as my mentors.
What are, outside of work, we talked all about work. What's your hobby, passion? What do you like?
I used to play cricket in school, in college, and I'm still really, really passionate about cricket. So last year, for the first time, World Cup happened in US, and I was super excited about it. And and US did well. So I think if there is any opportunity for me to actually watch or play cricket, I always jump in. It's one of those things I cannot forget. It's something that I will watch regardless of what time the game is at. I will wake up in the middle of the night. I did not actually. I did not. But I had the opportunity to go there, but I did not. I missed that out. But I'm definitely planning to attend more games here now. Oh, by the way, they started doing this cricket league here that is becoming popular. So in US now, they just ran that's mostly in Texas, but it actually went well. A lot of international presence, and it's becoming very, very popular. So I'm excited about cricket in US now.
The US IPL. That's
a UPL.
UPL. Yes, correct. All right. And what would you tell? Final question. What would you tell a young Brijesh, knowing what you do now, about work, life, anything?
I think both my work and my personal life have been a whole bunch of just right accidents. They just happened at the right time at the right place. I met my wife very similarly. We just got connected, in an accidental, random way, where she had won some award for writing a poem, and I read it, and I just responded to her, and then we have been together for 23 years now.
I hear a movie coming on.
She's very likely going to write a book on this. She's a writer. She's writing a book right now, but different topic. But what I would say is, you should take life as it comes to you. Sometimes a lot of planning may become a burden. And sometimes having an open mind to what's coming to you, what's coming at you, and being receptive, sometimes they're challenging, sometimes they're inviting, sometimes they're exciting. But having an open mind about this might be a good path forward versus, oh, I already have a plan, I can't do this, could lead to a much more exciting and adventurous life. And I would say, all of my big events, they were not completely random, but they were also not that thought through in terms of, I must do that. I have to go join Apple was never my plan. I have to go join NVIDIA was never my plan. But when you are in the moment and you do your analysis of, is this the right option for me? I selected the right option, and most of them have turned out right. Some of them you just learn from it, and those are good too.
Well, Brijesh, thank you very much.
Thank you so much, Nitin.